y'all, we're going to continue the academic chemistry lessons. So we are in Unit 1, Matter and Measurement, Topic 6, Measurement, and we are doing Part 2, which is the start of the math unit, and we're going to talk about rounding. So you guys went over rounding probably way back in the day, so some of this is going to be review, and maybe this is new for you. Maybe you skip rounding, so we're all just going to pretend that we have zero background knowledge of rounding and go through all the rules together. You may need to truncate, which is a great word if you don't know. It means to cut stuff off, your measurements in chemistry to adjust the total number of sig figs, and this is called rounding. Now, we're not going to go over today how to know how many sig figs to keep. For every point that I give you today for the lesson, I'm going to tell you how many sig figs or where we're doing the rounding. In the next 2 videos, we'll go through the math that says what the rules are, so you'll be able to predict where the rounding is, but for now, we'll just go over it. So here's a number. Let's say you have this measurement, 4,580.004 meters. And for reasons that we won't go over, you are only keeping 2 sig figs. So if you look at it right now, every single number in this measurement is a significant figure. So I have 1, 2, 3, 4, 5, 6, 7 sig figs. So if I only want to keep 2, it's going to become 4,600 meters. Notice both of these are essentially the same. It's just this only has 2 sig figs, but it's very, very, very close to my initial number. Okay, so rounding rules. Number 1, and this might be one of the most important ones, the original and final measurement must essentially be equal. So the essence of what you're measuring stays the same, it's just the precision is going to change. You're going to determine which digit should be the last sig fig. Now, like I said, for the sake of this lesson, I'm going to tell you which one the last one is, but once you learn the math rules for addition, subtraction, multiplication, and division, you'll be able to figure out which one will be the last one. Once you figure out what your last digit is, you're going to look to the digit after the last digit. If it is a 0, 1, 2, 3, or 4, then your last kept digit where you're rounding stays the same. If it's a 5, 6, 7, 8, or 9, then you're going to bump it up or round it up to the next digit. And that's because it's over half, so it's closer to the next number than it is to the number it's at. For the numbers after the rounded digit, what do? If they are before a decimal, you're just going to change them to 0. They become placeholders. If it's after a decimal, cut them off, because if you kept them, they'd be significant, and we're trying to get rid of some. At the end, check to make sure you have the right number of sig figs. If not, you need to convert to scientific notation. So if you remember from when we learned about scientific notation, everything in the coefficient is significant. So if you just take whatever digits you want to keep and put those in the coefficient, then you're automatically going to have the right number of sig figs. If you're already in scientific notation, you only change information in the coefficient to do rounding. Do not touch that 10 to whatever power. That stays the same because those are your placeholders. So if you change those, you change the essence of your number. Okay, so let's do some practice. We're going to round everything to 2 sig figs. Now, like I said, in the future, the number of sig figs you keep or where you keep it is going to change, but for these examples, we're just rounding to 2 sig figs. So in this measurement, 5,920,301 meters. What are our first 2 sig figs? Because if we're keeping 2 sig figs, the first 2 are the most important. So 5 and 9 are our first 2 sig figs. Those are our first 2 non-zeros. So if I'm rounding this, I look at the 5 and the 9, then I look after. The 2 does not bump it up. So I keep my 5, I keep my 9. The rest of these digits here, since they're before a decimal, they all become 0, and don't forget your meters. Let's do another one. 38.7492 liters. What are our first 2 sig figs? So our first non-zero number is the 3, and then 8 is still significant, so that counts. These are the digits where we're rounding at the end. The 7 bumps up the 8, so this is going to give us 3, 9. These digits left over, the ones we didn't highlight, are after the decimal, so they get cut. So we just have liters. The next example, 0.00403. My first 2 sig figs. So if I start on the left, the first non-zero digit is this 4. The digit right after it is the second. So if I'm rounding to 2 sig figs, I'm rounding at this position. 3 after it does not bump it up. So this is going to stay the same. The 0.00, those are your placeholders. The 4 and the 0 stay because the 3 does not bump it up, and keep your grams. The last one here, 479,000 atoms. So my first two sig figs, the 4 and the 9, are the ones that we are looking at. After this, the 7 is going to bump up the 9. And as you know, the number after 9 is 10. So it's going to convert this 9 to a 0, but then you have that leftover 1 in the 10 to go to the 4. So it's actually going to be a 5, 0. You can think of it as this being 49. The 7 bumps it up, so the number after 49 is 50. The numbers after where we did our rounding all changed to 0. When we look at this, 500,000 atoms only has one sig fig, and the goal was to have 2. So the two digits I care about are the 5 and the 0. I need to make both of those significant, and right now only the 5 is significant. So what I'm going to do is I'm going to take the 5 and the 0 and bring it down, and I'm going to put it in scientific notation. Now I can't have 50 in my coefficient, so I need to add a decimal. And then I need a 10 to what power? So you have to say how many times did I move the decimal from here to there, and it'll be 10 to the 5th atoms. So now both of my significant digits come over to the coefficient, and everything is 2 sig figs. All right, best of luck with this lesson. Make sure you talk to me if you have any questions. Otherwise, I'll see you in the next set of notes.